1% of its mass at a speed of 2000 meters per second in the first second. In the first second. In the first second. In the first second. Find the average acceleration. Find the average acceleration. That's the question. So in this case also we will be using the same equation. What is called right? F is equal to dm by dt into u. F is equal to dm by dt into u only. Okay, but remember, dm is equal to 1% of its rest mass. Understand? That means dm is equal to 1% means 1 by 100 of the rest mass. Rest mass is m0. That is m0 divided by 100. What is m0? M0 is the rest mass of the rocket. This is the condition. Right? Okay. Time is equal to what? Time is equal to, on the first second, it's 1 second. Therefore, F is equal to, find the average acceleration you have to find out. Right? Okay. Now, F is equal to dm. Dm is equal to m0 divided by 100, the whole divided by 1 into u. U is what? How much it is? U is equal to 2000. Therefore, this is equal to m0 by 100 into 2000. This is equal to 20 m0. This is 20 m. F is equal to 20 m0. So the typical thing is that this 1% of its mass of the rocket, rest mass of the rocket is m0. In the first second, what is happening? 1% of the mass is reduced. 1% of its mass is reduced. 1% of the mass at the speed of ejects to 1% of 1% mass ejected means the rate of loss is equal to 1% per second. 1% per second is equal to 1% per second. 1% means m0 by 100 divided by 1 per second. Right? dm by dt into 2000. You got F is equal to 20 m0. Am I correct? But F is equal to M. But F is equal to M. Right? Therefore, A is equal to M0A. M0A. That is equal to F divided by M. This is equal to 20 M0 divided by M0. That is equal to 20 meter per second. Like this, the question is done. Right? Okay. So there are several questions we have to do. One more question I am going to explain here. This is question number. This I think you might have written it. Right? With great interest, you will write these questions and understand the matter thing, and also will collect more and more questions of and then it's the questions of different ideas. Right? Different logics, what I say. Different logics that has to be applied in questions that you have to collect. That is the most important thing. A body of mass 20 kg is suspended. This is question number 11, I suppose. Question number 11. Right. A body of mass 20 kg is suspended. As shown in the figure. As shown in the figure. Find the value of K1, K2. Find the value of K1, K2, K2. K1, G is equal to 10 meters per second. The G means acceleration due to gravity. Thing is given here, there is a wall here like this, right? This is a situation. A wall or something like that. Okay, right. This is that means yeah, this is a spring, right? This is at this point also. Now it is hanging down like this is 20 kg. This is 20 kg. So it is actually hanging from this point. Here it is again pulled in this direction. So here there is a tension. This tension is T1. And here there is a tension because towards the point where the string is tied, towards that point of the tension, this is T2. So we have to find the value of T1 and T2, and only you have to calculate. Right? So in this case, what we have to do is, suppose this angle is also given, this is equal to 30 degrees. You can resolve this into two components. T1 can resolve into two components. It is acting along, yes. So T1 can resolve into two components, one along this direction and other along this direction. If this is 30, naturally this also will be 30. So this component of T1 will be equal to T1 cos 30. T1 cos 30. And this component will be equal to T1 sin 30. So T1 is resolved into two components because T1 is acting on because the body is hanging down like this. Therefore, and this is at this point also. Here also there is a tension. Here also there is a tension, right? When it's toward the point of suspension only, always the tension is acting. So in this case, what is this that T1 cos 30 is equal to T2 because this is an equilibrium. This T1, this suppose this is the point where all the forces are acting. This point is an equilibrium. Therefore, this force is equal to T1 sin 30 is equal to 20 into G. mg actually, force is mg. This is mass, 20 mass. 20 kg is the mass. Therefore, force acting downward is what? 20 into G. Okay. These two forces are balancing. Which forces? T1 sin 30 and 20G are balancing. In the same way, T2 is balancing T1 cos 30. So we can write T1 cos 30 is equal to T2 first. T1 cos 30 is equal to T2. Why? Because this point is in equilibrium. This point is not moving along this direction, not moving along the other direction, the direction of T2. So the point T2 is in equilibrium. When two forces are acting at a point and the point is in equilibrium or the body is in equilibrium, then we can equate these two forces are equal in magnitude but opposite in direction. Magnitude I am writing, right? Okay. Am I correct? Okay. Again, T1 sin 30 is equal to this one. T1 sin 30 is equal to 20 into G. 20 into G also we have. So this equation we will take first. T1 can be calculated. That is T1 into sin 30 is equal to 1 by 2 is equal to 20 into G. 20 into 20 into 10. Right? 20 10 is equal to what? This is equal to 200. Therefore, T1 is equal to 1 by 2, what is that? 2 into 200. That is equal to 400 Newton you are getting. Am I correct? Yeah. T1 obtained, put in this value. This is putting this value in equation 1. Putting this value in equation 1, we will get what? T1, that is equal to 400 into cos 30. Cos 30 is equal to root 3 by 2. Cos 30 is root 3 by 2. That is equal to T2B. That is equal to 200 root 3. Therefore, T2 is equal to 200 into root 3 Newton meter. So these are simple questions. You are beginners, so these are very important to understand how the T1 and T2 etc. are calculated by resolving forces, right? And this is equilibrium force. So this question actually coming from equilibrium of force. Several forces are acting on a body, and the body is in equilibrium. Then, in the same straight line, the two forces acting in opposite direction having equal magnitude, that can be equated. so that we can calculate T1, T2, etc. So this is the question about, right? So other questions we will discuss. There are so many questions I have to discuss. Today I am finishing this one because you will get bored if I go with the problems like this. So we will take time the next day. We will come with again new variety of problems. Till then, bye bye. Thank you.